Hi friends, welcome to the lecture of linear algebra. Let us see some examples depending on the characteristic value and characteristic vectors. Find characteristic values and characteristic vectors over C. Okay. First one, matrix A equal to 0, 1, 0. Okay, now we have to find out the characteristic value and characteristic vectors of this matrix A. Given that A is a matrix of order 2 cross 2. Now to find out the characteristic values, we have to first find out the characteristic polynomial of this matrix, and we know that how will you find out the characteristic polynomial of a given matrix. The characteristic polynomial of matrix A is given by determinant of xi minus a, and which is nothing but determinant of x minus 0 minus 1 0 x, and which is nothing but x square. Okay, now this one is the determinant of xi minus a equal to x square is a characteristic polynomial of a given matrix, that is which is nothing but some f of x, and we know that the characteristic equation of a matrix is nothing but determinant of xi minus a will be equal to 0. So the characteristic equation of a is given by f of x is equal to 0, that is x square will be equal to 0, which implies x equal to 0 0 are the eigenvalues of matrix A. So 0, 0 are the two eigenvalues of the matrix A. Now we have to find out the characteristic vector corresponding to eigenvalue 0. Let capital X equal to x1 x2 be the characteristic vector corresponding to eigenvalue 0. So a of x is equal to c into x. C is nothing but 0. The 0 into x. A is nothing but matrix which is nothing but 0 1 0 0. X is x1 x2 which is equal to 0 into x1 x2. Okay. So which is nothing but x1 0 1 0 0 x1 x2 of. Now from this x2 equal to 0 and x1 is equal to something k, since here 0 into x1 is 0, 1 into x2 will be equal to 0, and x1 equal to anything which is an arbitrary constant k, which is not equal to 0, and k is any constant. So here we get the values of x1 and x2. Now we have to put these values of x1 and x2 in given characteristic vector x. So which implies the characteristic vector corresponding to eigenvalue 0 is x equal to x1 is nothing but k and x2 is 0. That is x equal to k into 1 0 is the characteristic vector corresponding to eigenvalue 0. Okay, now next example is second one example. Matrix A equal to 4 2 2 3 3 minus 3 minus 1 0. So we have given a matrix A which is of order 3 cross 3. Now the characteristic polynomial of A given by is given by determinant of xi minus a, xi minus a, and which is equal to x minus 4 minus 2 minus 2 minus 3 x minus 3 minus 2 3 1 x. So which is nothing but x minus 4 into x minus 3 plus 2 plus 2 into minus of 3x plus 6 minus of 2 into minus 3 minus of 3 into x minus 2. Okay, so which is nothing but x minus 4 into x square minus 3x plus 2 minus 6x plus 12 minus plus 6 minus 3x into minus 2 plus cx minus plus 9 minus 80 which is equal to x cube minus 3x square plus 2x minus 4x square plus 12x minus 8 minus 6x plus 6x cancel plus 18 minus 18 cancel 12 plus 6 18 minus 18. So which is nothing but x cube minus 7x square plus 14x minus 8. Now this one is the characteristic polynomial of a given matrix A. That is, characteristic polynomial of a matrix A is nothing but x cube minus 7x square plus 14x minus 8 will be equal to 0. Okay. Now we have to find out the characteristic values. For that we have to find out the characteristic equation, and characteristic equation of any matrix is nothing but the determinant of xi minus a will be equal to 0, which implies characteristic equation of A is given by x cube minus 7x square plus 14x minus 8 will be equal to 0, and we know that how to find out the roots. So first root is suppose 1 minus 7 synthetic division method 40 minus 1 into 1 minus 6 8 0. So first root is x minus 1 into x square minus 6x plus 8 equal to 0. Now x minus 1 minus 2 minus 4 minus 6 and minus 2 into minus 4 plus 8. So x minus 2 into x minus 4 will be equal to 0, which implies x equal to 1, 2, 4 are the eigenvalues of matrix. So here we will find out the eigenvalues by using this synthetic division method. Now we have to find out the characteristic vector corresponding to eigenvalues 1, 2 and 4. Okay. Now we will first find out the characteristic vector corresponding to eigenvalue 1. Let capital A's equal to x1, x2, x3 is the characteristic vector corresponding to or associated to eigenvalue 1. So by definition of characteristic vector and eigenvalue, Ax is nothing but lambda. Lambda is 1 into x, which implies A minus 1 into I of x is equal to 0, which implies, but A is nothing but, we know that A is 4, 2, 2, 3, 3, 2, minus 3, minus 1, 0. So here we have to subtract minus 1 from diagonal elements. 4 minus 1, 3, 2, 2, 3, 2, 2, minus 3, minus 1 of x1, x2, x3 is equal to 0, 0. Since it is a matrix of order 3 cross 3, it is a matrix of order 3 cross 1. So totally we get matrix of order 3 cross 1. Okay. Now, which implies, now subtracting this, now we have to use a row transformation. Subtracting R2 minus R1, we get 3, 2, 2. R2 minus R1, then these elements are 0. Now add R3 plus R1, minus 3 plus 3, 0, minus 1 plus 2, 1, minus 1 plus 2 again 1, x1, x2, x3, and which is equal to 0, 0, 0. Now so here we get 3x1 plus 2x2 plus 2x3 equal to 0, and x2 plus x3 is equal to 0. As x2 plus x3 is equal to 0, which implies x2 equal to minus of x3. Okay, now put x2 equal to minus x3 in this equation, we get 3x1, this we can this one as 1, this one as 2. Now 3x1 plus x2 is nothing but minus x3, minus of 2x3 plus 2x3 equal to 0. Minus 2x3 plus 2x3 get cancelled, which implies x1 will be equal to 0. As x1 equal to 0, x2 equal to minus x3. Let us take x2 equal to something c, which implies we get x1 equal to 0, x2 equal to c, and x3 is nothing but, as x2 equal to minus x3, then if we take x2 equal to c, then x3 is minus of c. Either we get x2 equal to minus c, x3 equal to c, or x2 equal to c and x3 equal to minus c. For your convenience, let us take x3 equal to c. If we take x3 equal to c, then x2 is nothing but minus of x3, and here x2 is, we get minus c, and x3 is plus. So now we get the characteristic vector corresponding to eigenvalue 1, which implies the characteristic vector corresponding to eigenvalue 1 is x equal to x1, x2, x3, and here we get the values of x1, x2, x3. x1 is 0, x2 is minus c, and x3 is c. which implies 3 into 0 minus 1 1 are the. So this one is the characteristic vector corresponding to eigenvalue 1. Now we have to find out the characteristic vector corresponding to eigenvalue 2, and finally we have to find out the characteristic vector corresponding to eigenvalue 4. Since 1, 2 and 4 are the characteristic values of the given matrix. Now let capital Y equal to y1, y2 and y3 is a characteristic vector corresponding to eigenvalue 2. Okay. Now, from definition, ay is equal to lambda. Lambda is 2y, which implies a minus 2i of y equal to 0. But a is 4, 2, 2, 3, 3, 2, minus 3, minus 1 and 0. Now we have to subtract 2 from diagonal elements. 4 minus 2, 2, minus 2, sorry, 2, 2, 3, 1, 2, minus 3, minus 1 and minus 2 of y1, y2, y3 is equal to 0, 0, 0. Now add R2 plus R3. We get 2, 2, 2. R2 plus R3, 0, 0, 0. Now add this R3, R1. Then we get R3 plus R1. Then we get minus 3 plus 2, minus 1. Minus 1 plus 2, 1. Minus 2 plus 2, 0 of y1, y2, y3 equal to 0, 0, 0. Which implies 2y1 plus 2y2 plus 2y3 equal to 0, which implies taking to common y1 plus y2 plus y3 equal to 0. This one, take this one as a equation 3, and minus of y2 plus y3 equal to 0, which implies y2 will be equal to y3. If we put y2 equal to y3 in 1, we get y1, y2 and y3 are same, which implies, sorry, minus of y1 plus y2 equal to 0, which implies y1 equal to y2. So if we put y1 equal to y2 in 3, we get y1 is nothing but y2. y2 plus y2, 2y2 plus y3 will be equal to 0, which implies 2y2 plus y3 equal to 0, which implies y2 is equal to minus of 1 by 2 y3. Okay, if we take y1 equal to c, let y1 equal to c, which implies, sorry, take y3 will be equal to c. y3 equal to c, then we get y2 is nothing but minus of 1 by 2 c, and we know that y1 is nothing but y2, which implies y1 is also minus of 1 upon 2 into c. So these are the three characteristics, three values of y1, y2 and y3. y1 is minus 1 by 2 c, similarly y2 is minus 1 by 2 c, and y3 will be equal to c. So the characteristic vector corresponding to eigenvalue 2 is, which implies the characteristic vector corresponding to eigenvalue 2 is y1 y1 y2 y3, and which is nothing but y1 is minus 1 by 2c, y2 is again minus 1 by 2 into c, and y3 is c. So we can write this as a c into, or minus of 1 by 2 into c is nothing but 1 minus of 2. So this one is the characteristic vector corresponding to eigenvalue 2. Now it remains to prove that, it remains to find out the characteristic vector corresponding to eigenvalue 4. Let z equal to z1 z2 z3 be a characteristic vector corresponding to eigenvalue 4, which implies a into j will be equal to 4 j, which implies a minus 4I of j will be equal to 0. Again, a is nothing but 4 2 2 3 3 2 minus 3 minus 1 0. Now we have to remove, sorry, subtract 4 from diagonal elements, which implies 4 minus 4 0 2 2 3 minus 1 2 minus 3 minus 1 minus of 4 of z1 z2 z3 is equal to 0 0 0. Now add these r2 plus r3, then we get 0 2 2 3 minus 3 0 minus 1 minus 1 minus 2 2 minus 4 minus 2, and which is nothing but minus 3 minus 1 minus 4 z1 z2 and z3, and which is nothing but 0 0 and 0. So after that, here we get, now add r2 plus r1, then we get 0 2 2 0 0 0 minus 3 minus 1 minus 4 of z1 z2 z3 is equal to 0 0 0, which implies 2 z2 plus 2 z3 is equal to 0, which implies z2 is nothing but minus of z3, and minus of 3z1 minus z2 minus 4z3 is equal to 0. But z2 is minus of z3, or z3 is minus of z2, and z3 is minus of z2, which implies minus of 3z1 minus z2. z3 is minus z2, which implies it is plus 4z2 is equal to 0. Minus of 3z1 minus z2 plus 4z2 is plus 3z2. So here we get minus of 3z1 plus 3z2 is equal to 0, which implies minus of z1 plus z2 equal to 0, which implies z1 is equal to z2. So let z3 is equal to c. Then we get z1 equal to, as z3 equal to c, and z2 is nothing but minus of z3, which implies z2 equal to minus c, and z1 is equal to z2, which implies z1 equal to minus c. Okay. So from this, z equal to minus C is characteristic vector corresponding to eigenvalue, and hence here we have find out the characteristic vector corresponding to all the eigenvalues 1, 2 and 4. Okay. Now we have to find the minimal polynomial of the matrix A equal to 7, 4, minus 1, 4, 7, minus 1, and minus 4, minus 4, and 2. So here we have to find out the minimal polynomial of the matrix A, where A is a matrix of order 3 cross 3, whose row elements contain 7, 4, minus 1, 4, 7, minus 1, minus 4, minus 4, and 4. Now to find out the minimal polynomial, first we have to find out the characteristic values of this matrix, that is characteristic polynomial of a matrix. And the characteristic polynomial of A is given by determinant of xi minus a. Determinant of xi minus a equal to 0 is the characteristic equation. Determinant of xi minus a is the characteristic polynomial, which is nothing but x minus 7 minus 4 1 minus 4 x minus 7 plus 1 plus 4 4 x minus, okay, which is nothing but x minus 7 into x minus 7 into x minus 7 into x minus 4 minus 4 plus 4 into minus of 4x plus 16 minus 4 plus 1 into minus of 16 minus 4x plus 28. So which is equal to x minus 7 and which is x square minus 4x minus 7x minus 7 minus 4 minus 11x plus 28 minus 4 plus, sorry, minus of 16x plus 16 minus 4 12 12 into 4 48 minus 16 plus 28 28 minus 16 12 plus 12 minus 4x, okay. So which is nothing but x minus 7 into x square minus 11x plus 24 minus 16x minus 4x minus 20x 48 plus 12 60, okay, and which is nothing but x minus 7 x square minus 11x plus 24 minus 3 into minus 3 minus 8 x minus 3 into x minus 8, since 3 minus 8 minus 11 and minus 3 to minus 8 24 minus of take minus 20 common, then we get x minus 3. Okay, now taking x minus 3 common, which is nothing but x minus 3 into, here we get x minus 7 into x minus 8 minus 7 into x minus 8 minus of 20. Okay, which is nothing but x minus 3, and this is what x square minus 7x minus 18x minus 7 minus 8 minus 15 minus 7 minus 7 into minus 8 plus 7 into 8 56 minus 20. Okay, so which is nothing but x minus 3 into x square minus 15x plus 56 minus 20 plus 36. Nothing but x minus 3, and its roots are minus 3 into 12, 36 minus 3 into minus 12 minus 15 minus 3 minus 12. So here we get x minus 3 square into x minus 12. So this one is the characteristic polynomial corresponding to matrix A. So the characteristic equation is nothing but this matrix x minus 3 in square into x minus 12 equal to 0. That is determinant of xi minus a equal to 0 is the characteristic equation corresponding to matrix A, which implies its roots are, which implies x equal to 3, 3 and 12 are the characteristic values. These are the characteristic values 3, 3 and 12. Now we have to find out the minimal polynomial. In previous lectures, we have proved that the characteristic polynomial and minimal polynomial of any linear operator or matrix of corresponding to that linear operator have same roots except the multiplicity. As here 3, 3 and 12 are the roots of the given matrix or a given characteristic polynomial, then 3 and 12 are also present in its minimal polynomial also. Characteristic polynomial is x minus 3 square into x minus 12, which implies 3, 3 and 12 are the roots of the characteristic polynomial. So minimal polynomial also contains minimal polynomial also contains the roots 3 and 12. 3 and 12. As it contains 3 and 12, then the possibility for minimal polynomial is m of x equal to x minus 3 into x minus 12. Either this or another possibility is minimal polynomial, as minimal polynomial contains x minus 3 and x minus 12 both, and the another possibility is x minus 3 square into x minus 12 only. These are the only two possibilities for the minimal polynomial for the given matrix A. Now first we have to check whether this one is the minimal polynomial of a matrix A. That is, we know that minimal polynomial of a matrix A is nothing but a polynomial fx is said to be a minimal polynomial of a matrix A if fx annihilates the matrix A, and it is the smallest degree monic polynomial which annihilates the matrix A. So fx is nothing but x square minus 15x plus 36. So to check whether this polynomial annihilates the matrix A, now we have to find out the values of a square, and we know that A is nothing but a square equal to a into e, and which is equal to 7 4 minus 1 4 7 minus 1 minus 4 minus 4 4 into 7 4 minus 1 4 7 minus 1 minus 4 minus 4 and 4. So we have to take the multiplication of, we have to find out the a square. 7 into 7, 49, plus 4 into 4, 16, plus minus 1 into minus 4, 4. Okay, 7 into 4, 28. 4 into 7, 28. Minus 1 into minus 1, plus 1. Okay, 7 into minus 1, minus of 7. 4 into minus 1, minus 4. Minus 1 into 4, again minus 1. Okay, now 4 into 7, 28, plus again 28, minus 1 into minus 4, plus 4 into 4 into 4, 16, 7 into 7, 49, minus 1 into minus 1, plus 4 into minus 1, minus 4, 7 into minus 1, minus 7, minus 1 into 4, minus 4. Now, minus 4 into 7, minus of 20, minus 4 into minus 4, minus 16, 4 into minus 4, again minus 16. Now, minus 4 into minus 4, plus 6, minus 4 into 4, minus 16, minus 4 into 7, minus 28, minus 4 into minus 4, plus 16. Sorry, minus 4 into 4, minus 16, minus 4 into 7, minus 28, 4 into minus 4, minus 16. Next, minus 4 into minus 1, minus 4, minus 1, minus 4, minus 1, 4, 4. So, a square is nothing but 49. 16 plus 4, 20. 49 plus 20, 59, 69. 28 plus 28, 56. 56 plus 4, 60. Minus 7, minus 4, minus 4, minus 8, minus 7, minus 50. 28 plus 16. 16 again 69. Minus 4, minus 7, minus 4, minus 50. Minus 16, minus 16. Minus of 32, minus 28. Minus 16. Again minus 16. 16 plus 4, 20 plus 24. So here we get a square equal to 69, 60, 69, 60 minus 15, 60, 69 minus 15, minus 60, minus 60, 24. Now we have to now we have to put these values in. That is, we have to find out whether this annulates given polynomial annulates the matrix A. So we get a square minus 15A plus 36I equal to 0. We have to show, but which is nothing but A square. A square is nothing but 69, 60 minus 15, 60, 69 minus 50 minus 60 minus 60, 24. Minus of 15 into matrix A. 7, 4 minus 1, 4, 7 minus 1, and here minus 4 minus 4, 4, plus 36 into I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. Now, which is nothing but 69 minus 15 into 7 minus of 105 plus 36. Okay. 60 minus 15 into 4, 60 minus 60. Again minus 15 into minus 1 plus 15. Again 60 minus 15 into 4 plus minus 60. 69 minus 105 plus 36 minus 50 plus again 50 minus 60 plus 60 minus 60 plus 60 plus 24 minus 15 24 minus 16 plus 36. Okay. Now, which is nothing but 69 plus 36, 105, 69 plus 6, 75, 75 plus 30, 105, which is 0, 105 minus 105, 0, 60 minus 60, again 0, minus 15 plus 15, 0, 60 minus 60, 0, which is again 0, 0, minus 60 plus 60, 0, minus 60 plus 60, 0, 24 plus 36, 60, 60 minus 60, again 0. So here, a square minus 15a plus 36I will be equal to 0. Therefore, the given polynomial mx equal to x square minus 15x plus 36 annihilates the given matrix A, and it is the smallest degree polynomial which annihilates the matrix A. Therefore, mx equal to x minus 3 into x minus 12 is the minimal polynomial. There is no need to check for a x minus 3 square into x minus 12, since here we have to find out the smallest degree polynomial which annihilates the given matrix. Okay. Now, homework. Find the characteristic value and characteristic vectors of the following matrices. A equal to 1 0 0. This one is the first one, and second one is b equal to 1 minus 1. So we have to find out the characteristic vector and characteristic values of these matrices. Thank you for watching the lecture.